This is the general form of a polynomial. You see that here we have the highest term in the polynomial going all the way down to the lowest term in the polynomial. These powers here, in general form, how it's written, is you always start with the highest power and go down to the lowest power. The numbers in front of these variables, the a sub n minus 1, a2, a1, and a0, these are called coefficients. They're going to be typically just numbers. And you'll see that the variable here is always the same. It's always x. Of course, it can be y, it can be z, but it's going to be always the same variable. Typically, we just use x. I will say on this last term here, x to the 0 equals 1. Typically, a naught x to the 0 is written just as a naught, or a sub 0. Polynomial can look like 3x to the 5th plus 4x squared minus 13x cubed. Oh, let me actually change these around just to write them in standard form. Here we have the highest power is 5, the next highest is 3, the next highest is 2, and you see that this is written in standard form. It goes from the highest power to the lowest power. Here too are the coefficients. We have 3, 4, and negative 13. And of course our variable is just x for this polynomial. You can also have polynomials like this, negative 13 plus pi x to the 15 minus 1,000,000.856 x to the 3. Wait, same idea here, right? We've got the coefficients and we got the powers. This doesn't have a power written here, which means it follows along this kind of idea where x to the 0 equals 1, so we don't write it. This is x to the 15, and this is x cubed. Now, x to the 15 is the highest power. That's not written first, so this isn't written in standard form. We rewrite polynomials into standard form because they're easier to work with when they have the highest power first, and then all the way going down all the way to the lowest power. So that would be standard form there. This highest power is called the degree. So the degree of this polynomial that I've written here, this degree is 15. In the previous polynomial, let me clean it up a little bit. The degree here would be 5 because 5 is the highest power. The reason why this is important is because polynomials, the behaviors of them, are typically determined by the degree of the polynomial. For polynomials that look like this, let's say 3x minus 5, this you may notice is a linear function. It's also a polynomial. The degree here is 1. If it's not written, then you just write a 1 there. And of course, if I have a number by itself, like 63, this is a constant function because it's just a number, but it's also a polynomial, and the polynomial degree is 0. That's the degree there. Now, there are 3 types of polynomials that we work with a lot, and those are called the monomial, the binomial, and the trinomial. I guess it's like Mon is 1, and then nomial is number. Binomial is 2 numbers. Trinomial is 3 numbers. That kind of thing. And what this refers to is how many terms are in a polynomial. So a monomial would be like 4x cubed. There's nothing else added onto it, so there's a single term inside of this polynomial. A binomial has 2 terms in it. 2x to the 15 minus 3x to the 9. That has 2 terms, so it's a binomial. A trinomial, as you can guess, is 3 terms. So let's say negative 0.3 x cubed plus 5x minus 13. This has 3 terms, so it's a trinomial. Now the reason why we specify is because monomials are probably the easiest things to work with. Binomials and trinomials are fairly common, and so we specify them differently, but they're all just polynomials. So all the properties we work with polynomials apply to all of these. It's just kind of a naming convention that we use in mathematics. Everything above a trinomial is called a polynomial. All right, let's do some arithmetic with polynomials. So if we're just adding and subtracting, 2, 6 into the 5th, then these are actually quite simple. Really all we're doing here is combining like terms. So in this case, we have a binomial because there's 2 numbers, right? There's 6, you do like this, 6 into the 5 plus 1, that's two terms, so it is a binomial. The next one here has 2m to the 5th, 9m, and negative 1. That has 3 terms, so it's a trinomial. But it doesn't matter how many terms there are, you always follow this method. If we're just adding 2 polynomials together, then really all we need to do is drop the parentheses, because they don't actually mean anything in the long run, right? If I drop the parentheses here, like this, I haven't actually changed the problem at all. There's nothing that changes from it. And so now I can just combine like terms. Well, we have a 6m to the 5th and 2m to the 5th, which gives us 8m to the 5th. Then we have a 1 and a negative 1, which cancels. And we have a 9m. So we're just going to do 9m. All right, I have written the answer here in standard form. The highest degree first, which is m to the 5th, and then the next highest, and all the way down to the lowest. So 8m to the 5th plus 9m, that would be your final answer there. Okay, so that's addition. Quite simple. Just drop the parentheses and combine like terms. For subtraction, we need to first distribute the negative, because if I were to just drop the parentheses here, I'd actually be changing some stuff. So first, distribute this negative just like you would if you had a number in front. Think of it as like a negative 1 and distributing that throughout. Then we have 8x squared minus 3x. Then we have minus 5x plus 5 plus 8x squared. And at this point, we're just combining like terms. So we have an 8x squared plus an 8x squared. Oops, gives us 8 plus 8 is 16, so we get 16x squared. Then we have negative 3x minus 5x. Gives us a negative 8x. And finally, we have plus 5. So we get plus 5. And that's all the terms, so that is our polynomial. Again, written in standard form, highest power to lowest power. So addition and subtraction are done quite simply, with addition dropping the parentheses and adding like terms. Subtraction, make sure you distribute the negative in first, and then combine like terms. Now, multiplication is all about distributing the terms into every other term. If you have two monomials, it's really just multiplying everything together. So for instance, 8x cubed y squared times negative 3x squared y cubed. These are two monomials, and they're multiplying together. This is a little bit of a special case because we don't have multiple terms. We just have one term times one term. And really this is just multiplying everything together that are like things. So 8 times negative 3 gives us negative 24. Then we have x cubed times x squared. If you multiply like bases, then you add the exponents, so we get x to the 5th. Then we have y squared times y cubed. Multiplying like bases, add the exponents, so we get y to the 5th. And that's all we have to do. So a monomial times a monomial, quite simply, you just multiply how you would expect. And that's all there is to it. Now, when you do anything besides monomial times monomial, that's where distribution really plays a key part. So for instance, 4xy is a monomial. We're multiplying this into a trinomial of that. To do this, all we have to do really is distribute the monomial into each one of the trinomial's terms. So we'll do the blue first. We really just have an x squared times an x squared on the inside, giving us x to the 4th times y. Nothing else really changes there. The next thing, we have negative 4 times positive 7 is negative 28. X squared times x is x cubed, right? We have x squared times x to the 1, so we add the powers. And y times y is y squared. All right, lastly, we have negative 4x squared y times negative 6y cubed. Negative 4 times negative 6 is positive 24. X squared is not multiplying anything, so that's just x squared. And y times y cubed is y to the 4th. We always have to ask, is there like terms after we do the multiplication? Because we need to combine those. In this case, there's not. There's no variables that are exactly the same. So this is the answer to that multiplication. All I did there was distribution. Let's look at another one. 2x minus 5 times 5x squared plus 4x plus 7. This is a binomial times a trinomial. And again, all we have to do is distribution. Make sure you distribute all of the first thing into all of the second thing. So for instance, I'm going to first do 2x times 5x squared, then times 4x, and then times 7. And then I'm going to take negative 5 times 5x squared times positive 4x times positive 7. That's the method that you always do for multiplying polynomial times polynomial. Take the terms in the first polynomial and just distribute them into all of the second polynomial. Okay, let me get some room here. The first polynomial is really, let me rewrite this in a slightly easier way just to show you the distribution. We're really just taking 2x times 5x squared plus 4x plus 7 and subtracting 5 times the same exact polynomial. That's just another way of writing what I did here. We're still going to do the 2x times everything and the negative 5 times everything. It's the same method, but I'm just showing you why we're doing the distribution. Okay, so 2x into all the terms. 2x times 5x squared is 10x cubed. 2x times positive 4x is 8x squared. And 2x times plus 7 is plus 14x. Okay, that's the first one done here. So we can move on to the -5, distributing into everything. -5 times 5x squared is -25x squared. -5 times plus 4x is -20x. And -5 times plus 7 is -35. Now we definitely do have like terms, so let's look at those. 8x squared and -25x squared, and then 14x and -20x. Those are the only like terms. So I'm going to take this in parts. I'm going to look at the highest power first and go down from there. The highest power is 10x cubed. That does not have any other like terms, so I'm just going to write 10x cubed down. The next highest power is the squared, which is the orange. 8x squared minus 25x squared is -17x squared. Then we move on to the purple, because that's going to be the next highest power, which is just x. 14x minus 20x, that is -6x. And finally, we have the number by itself, which is the constant term, -35. And that is our final answer. It's in standard form, highest power to lowest power, which is the best way of writing it out. Again, all I did here is I just distributed this 2x here into all the terms, and then I distributed the -5 into all the terms. That's all there really is to multiplying polynomials. Let's look at this one here. 3x plus 5y squared. So this thing we're going to want to first expand the polynomial out. And now we're just doing distribution. Now you see that this is a binomial times a binomial. It's two numbers times two, or two terms times two terms. You can use the FOIL method, which is first, outer, inner, last. But really all that is saying is distribute the 3x into everything, and then distribute the 5y into everything. So 3x times 3x, this is going to be 9x squared. And then 3x times 5y is 15xy. Then we're doing the 5y here. 5y times 3x is 15xy. 5y times 5y is 25y squared. Combining like terms, there's really only two that are like terms. And I'm going to write a 9x squared, and the like terms are 15xy and 15xy, which is 30xy, and then 25y squared. Now I wrote it in this way because the x is the highest power. That's the highest power first of the x's, and x is before y in the alphabet. When you have mixed numbers or mixed variables like this, there really isn't a standard form of writing it. We typically try to write it, though, in alphabetical order, going from highest power to lowest power. So I'm writing the x's first, and then the y's. But you could write it as 25y squared first, and then 30xy, and then 9x squared. But that is a binomial times a binomial. But again, whenever you multiply polynomials, all you're doing is distributing the first polynomial's terms into the second, and then combining like terms in the end.